Imagine you press a button. Simple as that. Just a button. Now imagine that button, instead of turning on a light, detonates a bomb 1 billion light years away. Instantly. Sounds powerful, right? Sounds like the kind of thing an advanced civilization could build. But here's the problem. If that were possible, time would cease to exist. I'm not speaking poetically. I'm talking physics. If anything could move faster than light, there would be observers in the universe for whom the effect would happen before the cause. The bomb would detonate before you pressed the button. The glass would be shattered before it fell. You would die before you were born. And the universe, apparently, refuses to let that happen. The speed of light is not an engineering limit. It's not something humanity will overcome with enough technology. It's a protection built into the very fabric of space and time. And understanding why it exists will completely change the way you see reality. Before we go further, let me give you a few facts that most people have never stopped to think about. The sunlight warming you right now left the sun's core approximately 100,000 years ago. It spent 100,000 years trapped inside the sun, bouncing between particles, and then crossed 150 million kilometers to reach you in just 8 minutes. When you look at the night sky and see a star, you're not seeing where it is. You're seeing where it was years, decades, sometimes millions of years ago. Some of the stars you see tonight probably no longer exist. You are literally looking into the past. And here's the most unsettling part. There's a region of the universe we will never be able to see. Not because we lack powerful enough telescopes, but because the light from those regions will simply never reach us. The universe is expanding too fast. There are galaxies moving away from us at speeds greater than the speed of light, and that doesn't violate any law of physics, because it's not matter moving, it's space itself expanding. This already begins to show that the speed of light is something far deeper than just a maximum speed. If you made it this far and your mind is already spinning, just wait for what's coming next. Drop a like right now. That simple gesture helps this content reach more people who also want to understand the universe for real. And if you're not subscribed yet, hit subscribe and turn on notifications. The next videos will keep going in this direction. Physics, the cosmos, and the questions most people are afraid to ask. Now let's go deep. In 1905, Albert Einstein published what became known as the special theory of relativity. But what he actually did was something far more radical than simply establishing a maximum speed. Einstein started from two seemingly simple principles. First, the laws of physics are the same for every observer in uniform motion. It doesn't matter whether you're sitting in a chair or traveling on a train at 300 kilometers per hour. Physics works the same way. Second, the speed of light in a vacuum is always the same, approximately 299,792 kilometers per second, regardless of who measures it or how the observer is moving. That second principle sounds harmless, but it completely destroys human intuition about time and space. Think about it this way. If you're in a car going 100 kilometers per hour and you throw a ball forward at 50 kilometers per hour, someone standing on the sidewalk sees that ball moving at 150 kilometers per hour. The speeds add up. Simple. Now replace the ball with a beam of light. You're on a rocket traveling at half the speed of light, and you shine a flashlight forward. How fast does the person standing still see that light move? Classic logic says 1.5 times the speed of light. But no, the person standing still measures exactly the same speed of light that you measured. The speed doesn't change. For that to be true, something has to give, and what gives is time and space. For the speed of light to be constant for all observers, time must pass at different rates depending on how fast the observer is moving. The faster you move through space, the slower you move through time. This is a metaphor. It's measured with atomic clocks on airplanes and satellites every single day. To understand why the speed of light is an absolute limit, you need to understand the concept of spacetime. Einstein, together with mathematician Hermann Minkowski, showed that space and time are not separate things. They form a single four-dimensional structure, spacetime, and every event in the universe happens at some point in that structure. Now comes the most powerful part, the light cone. Imagine an event, say an explosion. That explosion happens at a specific point in space and time. From it, light expands in every direction like a growing sphere. If you represent this on a diagram with time on the vertical axis and space on the horizontal axis, that sphere of light traces a cone opening upward, the future light cone. And there's also a cone opening downward, the past light cone. What sits inside the future light cone are all the events that can be causally affected by the explosion. Light, or anything slower than it, can reach those points. What lies outside the cone is called the space-like separated region. And here is the universe's absolute rule. No signal, no information, no causal influence can cross outside the light cone. Why? Because if it could, causality would break. Causality is the principle that causes precede effects. The cause comes first. The effect comes after. Seems obvious. But special relativity reveals something disturbing. The order of events can change depending on the observer. Two events that are simultaneous for one observer may not be simultaneous for another observer in motion. This is called relative simultaneity, and it's real, verified, not science fiction. But, and here's the crucial point, this only applies to events that are outside each other's light cones. For events that have a possible causal connection, meaning events inside each other's light cone, all observers agree on the order. The cause always comes before the effect. For every single observer in the universe, the light cone is precisely the boundary that protects this. If something could move faster than light, it could escape the cone, and then we would find an observer for whom the effect came before the cause. We would have a causal violation. The universe would become logically incoherent. The speed of light is not a limit because physics is lazy or because technology hasn't gotten there yet. It's a limit because exceeding it would destroy the logical structure of reality itself. There's another angle to understand this limit, and it's equally devastating for anyone dreaming of traveling faster than light. As an object with mass approaches the speed of light, it requires increasingly more energy to keep accelerating, not linearly, exponentially. Einstein's equation, E equals mc squared, is just the beginning of that. The relativistic mass of an object increases as its speed increases. To bring any object with mass to the speed of light, you would need an infinite amount of energy. Infinite, not very large. Infinite. This means objects with mass never reach the speed of light. They approach it asymptotically, getting closer and closer, but never arriving. Only massless particles, like photons, the particles of light, travel at the speed of light, and they have no choice. They cannot go slower or faster. They are born, exist, and cease to exist always at 299,792 kilometers per second. That's why light is the universe's ultimate messenger. It's the fastest any information can travel. Now comes one of the most fascinating parts, and one that seems to contradict everything we just said. The universe is expanding, and parts of it are moving away from us at speeds greater than the speed of light. How is that possible if nothing can move faster than light? The answer is precise. Special relativity forbids objects from moving through space faster than light, but it says nothing about space itself expanding. When the space between two galaxies increases, it's not that the galaxies are moving through space away from each other. It's the very fabric of space that is growing between them. There's no causal violation because no signal is being transmitted, no information is being sent. This defines what cosmologists call the cosmological event horizon, the boundary beyond which no information can ever reach us, not because the universe places a wall there, but because space is growing too fast for light to catch up. There are galaxies we will never see, that exist right now, as you watch this, but are beyond the eternal reach of any telescope we could ever build. Black holes are the ultimate test of the speed of light as a cosmic limit. At the singularity of a black hole, the curvature of space-time becomes so extreme that light cones literally tilt, to the point where the future of any object inside the event horizon points inevitably toward the singularity. Inside a black hole, the event horizon is not a physical barrier. You feel nothing as you cross it, but after crossing, all causally possible paths lead to the singularity. There is no trajectory in space-time that leads back out. The light cone is tilted in such a way that forward in time means deeper into the black hole. Not even light escapes. Not because gravity is faster than light, but because space-time itself is curved in such a way that there is no outward direction inside the horizon. So here we are. The speed of light is not a speed. It is the speed of causality. It is the rate at which the universe processes cause-effect. It is the heartbeat of reality. Everything that exists, every particle, every force, every interaction, happens within the boundaries its value imposes. The universe is, in a sense, an information processing machine. And 299,792 kilometers per second is the maximum processing rate of that machine. But here's what no one tells you in the shallow summaries of this topic. There is an equation in quantum physics, the Schrödinger equation, that, under certain interpretations, seems to propagate instantaneously. The collapse of the wave function, quantum entanglement, particles that appear to communicate instantly, regardless of distance. Einstein called it Spuk-half-Fernwirkung, spooky action at a distance, and he hated the idea. Experiments have confirmed quantum entanglement is real. Two entangled particles, separated by any distance, seem to know what happens to the other one instantly. Does that violate the speed of light? The short answer is no, because you can't use entanglement to transmit information. The correlation exists, but you don't control the outcome, so no actual signal travels between the particles. But the long answer is far stranger, because physicists still debate what this means. If no signal is traveling, what is actually happening? Is there some deeper structure of the universe, beneath space-time, where entangled particles are somehow still in the same place? Is there something more fundamental than space-time itself? Is there something more fundamental than causality itself? These are the questions that the brightest theoretical physicists in the world are working on right now, and they suggest that what we discovered today about the speed of light may be only the surface of something infinitely deeper. If this video made sense to you, or if it left you with more questions and answers, that's exactly the sign that you're on the right track. Subscribe to the channel now and turn on notifications so you don't miss the next video on quantum entanglement. And in the comments, tell me, do you think there's something more fundamental than space-time? What kind of structure could lie beneath causality itself? See you then.